playing with the garbage collection. So this is Simon Dev, amazing YouTuber. For those that are wondering, no, I have not fixed my screen tearing. You are welcome. I'm still on i3. Everyone's like, oh, don't worry, you just adjust all these settings. I've tried adjusting the settings. I cannot get screen tearing to go away, but Sway somehow alleviates it all. So I just haven't done it yet, okay? I haven't done it yet, okay? I had to undo Sway due to some presentation problems I had, and now I'm willing to go back.
Let's get right to...
You need PCOM. You're right, because I'm definitely not running effing PCOM. Fine. I'm running PCOM. Look, PCOM's now officially running. Screen tear will still happen. It's not PCOM. Okay, I don't want to talk about it. Shut up about the screen tearing. All right, here we go. We're going to do screen tearing, everybody. Oh, Windows helps.
Let's get right to the point, shall we? Is JavaScript's garbage collector as bad as some people think it is?
I wonder if any of these things are me. I'm like, who said these things? Are they me? Because this is really what so me personally, so I'm just gonna come out there and say it. It depends on the activity. On a server, an improvement in garbage collection rate can make a huge difference if your server's under load. It can make an enormous difference. I assume with games, you have a lot of the same things. It just depends on how they're all me. They might all be me.
I have no idea. So let's poke at this a bit and see if we can learn something.
Yeah.
Basically, when you allocate memory, in languages like C++, you have to explicitly free it. Otherwise, you have a memory leak.
Like playing Worm or something.
In languages like JavaScript, C#, Java, Go, these are all garbage collected languages. They handle a good chunk of the memory management for you.
Yep. Abstract memory management, though, also ends up being, it's not the most efficient form. But let's keep on going. But it's really lovely to program.
Memory,
right?
At some point, JavaScript has to decide when you're done with it.
Yep.
So if I allocate an array, here's my array somewhere in memory. And then I fill that array with stuff. So a number, a string, it really doesn't matter. Now, if I go and null out one of the entries in the array, this little blob of memory here kind of gets left stranded now. It has no connection to anything anymore. Nothing refers to it. In other words, it's not reachable.
Mark and sweep,
if we
classic
start at
mark
a
and
root
sweep
object,
going on right here.
We can't reach that little blob, and thus it's garbage.
Yep.
It's safe to reclaim that memory because nothing can possibly be using it anymore. That's the general idea anyway. Let's see it in action with some code.
There you go. If you haven't read about it, I believe V8 has a really good breakdown of this. Mark and sweep V8. If I'm not mistaken, they have like a whole... Yeah, they have their whole talk about it. Pretty cool. Pretty neat stuff. Lots of stuff. Blah, 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 blah. They also, they have it for all their V8 stuff. It's pretty interesting, the memory management stuff. It's pretty interesting. It's pretty cool. Again, I cannot believe that V8, that team has created an environment in which JavaScript can potentially run fast, which is shocking. All right, I will increase the speed.
What I've done here is I've written a really dumb test that just spam fills an object with random strings and other objects. This is called by a request animation frame, kind of.
This is not an educational comment. Remove the captions. No, I keep captions, baby. Get out of here. Stop telling them about business. Everyone's like, shut up. Twitch, I'm going to throw punch you.
Like you would in a game loop. So see here, I create data, set it to empty to start. Then I loop over and create a bunch of junk in there. Basically a linked list of objects with random names. And these all have to allocate memory. The strings take up memory, as do the objects themselves. This data variable isn't used anymore at the end of each loop, so we're achieving our goal of wasting.
Hold on. We start at the start. Oh, he's created like a linked list, sort of. Right? Interesting approach. This is a very interesting approach. So he's creating an object with a singular key, as far as I can tell. Take the singular key, do this, and it's going to create a linked list 20 deep 100,000 times, right?
Memory and forcing the garbage collector to act. So in order to actually test this, you need to be able to measure how much time JavaScript spends in garbage collection.
Or actually, really the memory tab.
You could pull up DevTools and hit the performance button and dig around there, but there's actually another way that's slightly less known. This is Chrome tracing, the backbone of Chrome's performance testing framework. Hundreds of benchmarks measuring who knows how many thousands of metrics are built on this. In another life, I was an owner here and even led the infra team monitoring and processing all this data. It's pretty cool. You can see and attribute time to various calls, see IPCs between processes. In general, it just gives way, way more info.
If you've never used telemetry by Epic Games, it used to be by Rad Gaming Tools. This is very, very similar to that one. There are some, obviously, you have huge impacts into performance taking all this stuff, but it's fairly lightweight. You can see a lot of internal tools. It's the Chrome tracing tool, Perfetto.
For our purposes, I think it'll just be easier to focus on what we want to know, garbage collection events.
Yep.
So from here, you can start a trace, choose which events you're interested in.
You only select the things you need, which makes it so it's lower overhead.
And then start recording. You just need to wait a bit to capture enough of a trace. Just capture however long you want. You don't need to wait to 100%. This uses the Doom keys to move, WASD. So let's zoom in and we can look a bit closely at all these garbage collection events. And we can see that we were successful at provoking the garbage collector.
I wonder if he has any major GCs versus minor GCs, because there's also time in which you hold on to garbage. So one thing that he's not talking about is how long are you holding on to it? What's the difference between holding on to an object for a small period of time versus holding on to an object for a long period of time? They're very, very different. Doom keys, I always just called it WASD, but I guess, was the Doom the first one to do WASD? Oh, he'll talk about it? Awesome. Okay.
All these minor GC calls are V8 in action, reclaiming memory. If we're lucky, maybe we see some major GC calls in here too.
They can be very expensive.
These are both versions of V8's garbage collector in action. So that brings up an important question before we move on. What is a minor GC versus a major GC? That's a good question, Simon. Thanks for asking that.
Yeah.
V8
Simon
has a great blog post that talks in depth about Orinoco, their garbage collector, and goes through some of the high-level details on their collection strategy. There's this idea, the generational hypothesis in garbage collection, that most items die really young, also called infant mortality, because why not just use super morbid terms for memory?
I didn't realize they called it infant mortality. Damn. That is a little dark. I guess I didn't read the Wikipedia article on generational garbage collection. I mean, I knew that they called it a nursery. That's typically what I've heard is a nursery. I didn't realize we're also killing the baby at this point. Okay, it's strange.
Management. But as a super hand-wavy explanation, V8 basically divides allocations into new and old. Mm-hmm. You have the new generation and the old generation, and in essence,
Boomers,
allocations
Zoomers.
Start in the new generation. So if I allocate a string here, it starts out in the new generation, specifically the nursery section part of this new generation. Then a garbage collection pass happens, and let's assume that some objects are reclaimed and others aren't.
Yep.
If our string happens to survive the first garbage collection attempt, it gets copied out or evacuated into a sort of intermediate area. It's not old yet, but it's not brand new either.
Yep.
Another garbage collection event occurs, a bunch of other stuff gets reclaimed. If at that point we find that our object survives, if it's still in use, it gets evacuated out to the old generation. V8 makes this distinction so that it can apply separate strategies for the new and old generations. The minor GC, the scavenger, is optimized to collect from the new generation, while the major GC, which doesn't have a cool name like the mutilator or anything, does the heavy lifting of sifting through the old generation.
Yes, we found so interestingly enough, when I was at Netflix, when I was doing a lot of the recent profiling stuff, because I added in for one of our upcoming tools I've been kind of playing around with, I added in a counter for all the minor and major GCs. And I'd keep track of everything that's happening so that we could have performance regressions. And then I created something that would spam through the video player a bunch of events and kind of have the whole thing tested so that as we make changes, if we make a change that causes a bunch of more garbage collection, it will show up on a PR and fail your PR. Kind of a little clever thing, because garbage collection is really real. It can certainly cause a bunch of oopsie daisies. Yeah, by the way, I work at Netflix. If you didn't know,
you could call it the Reaper or something. So by looking at the trace of our first test, we can actually select the first.
So that means we have the baby killer and the euthanizer. Like what do we call this thing? Like just horrible names. Can we just come up with just horrifying names for those two garbage collections, minor and major? Obviously, we have the infant mortality. Now we need the other side. Damn.
First 10 seconds or so of the trace, and we can see that there were 384 occurrences of minor GC, averaging about 1.079 milliseconds each, and 56 occurrences of major GC at around 0.838 milliseconds each. So our test is getting V8 to do some minor and major GCs. So we can change this test around a tiny bit to try and poke the major GC into action.
I like it.
So what I've done here is I just take a random subset of the data and I stuff it into this .stuff, overriding whatever happened to be there. This .stuff is permanent, never deleted for the duration of the test.
Super clever way to test this. This is actually a fairly clever way to test this. I mean, I guess the one thing you'd have to do is go find out how long how often do major GCs happen? And you'd have to make sure it happens enough times, or how many times what's the frequency of minor GCs, and make sure that you can skip enough generations to go into the old fogey's home for a garbage. But this is super interesting strategy. Love this strategy. Super cool. Absolutely love this strategy. Very, very smart. Because I've done a lot of performance tuning, and I always have this thing where I usually just use a timer. And so normally I never thought about just using a global stuff it and then just keep rewriting over. So eventually that data also just dies, effectively creating multiple connections to the piece of data. Super, super clever, and I'll probably use this in my next test. I love that.
You keep a bunch of random things for a lot longer than a single call of do something stupid, and promote things to the old generation. When we get a trace of the whole thing, and we're just going to select the first 10 seconds or so of the trace, and we can see that this is indeed what happens. We managed to force the garbage collector to work a bit harder, and we've added some time to both minor GC and major GC. To try and understand the relationship between allocation patterns and minor GC and major GC...
Does anyone understand why minor GC ended up having a touch more work? The effective idea is that, remember, every single one of those objects had effectively 20 little baby objects on it. It was a linked list. And so some amount of those objects would last into stuff. And so that means your first round minor GC now has to hold on to something longer, which means that it's going to have to do more searches in those two buckets before it promotes it out of it, right? Or at least that's like, if that's exactly how it works, you have, young, intermediate, old. I'm not sure if that's exact. I don't know if there's a 3-bucket generational garbage collection. I'm not exactly sure how the garbage collection works, but effectively
fiddled with this a bit more.
Just means there's more objects to look.
Objects, but make them more complex. This is the trace here. We'll select the first 10 seconds again, and looking at it, minor GC isn't changing a whole lot, but major GC is changing quite substantially, nearly doubling the time taken versus the simpler cases. I poke at this a bit more by adding a setup step to the test, where I just allocate a whole bunch of random crap and store it. It's never referenced in the test, but it's there. When we look at a trace of that, we see our major GC calls getting much more expensive. Although there's fewer calls to major GC, each invocation is taking 26
the big
milliseconds,
kicker right there.
Which for a game would be basically a skip frame.
So this is actually a really interesting piece of information, especially if you're I assume most of you are working on servers, right? Using servers. So holding on to data longer, you're really understanding your garbage collection cycles and holding on to data longer. You like how I'm saying data? Why do people say data? Why do people add R on the end of things with that end with A? Anyways, because I've heard people say China and data. China. Anyway, so if you're building a server and you have to hold on to data long, you could imagine that a request can last quite a bit of time, quite a bit of time in computer time. Data, I believe Data from Star Trek would say it's an eternity, but it would happen and you'd be able to hold on to enough to actually skip through some GC cycles. You can make your major ones have these huge, long stops, and that's where you get these little request spikes. And so it's fairly interesting looking at this stuff. How can you move out of the major world and into the minor world? Because the minor world is almost always really, really fast and small. Star Trek nerd! Okay, first off, Brett Spiner is a champion. Okay, everybody else but Riker and Brett Spiner can just off. But just saying. People are going to be so
inexcusable. So that suggests that there's a relationship between the amount of crap you have allocated and how long the GC takes, which, is hardly surprising. It has to figure out what you're using and not using. It's not magic. If you were using another language where memory management is explicit, such as C++, it wouldn't matter how much or little you have allocated. There's no ongoing cost for having it allocated. You only spend time allocating or freeing. Whereas in JavaScript, there's definitely a tax on what's currently allocated. I tried a few more experiments to...
Not only that, but there's also, remember, there's the reason why you saw minor GC also increasing is that there's a whole tax of managing this memory and moving it up the chain. There's, remember that it's not free. So when you create squirrely marks, it's not just simply a give me a piece of memory. It's give me a piece of memory, keep track of that, put that into the stuff, make sure that we have a link to it. Then you have to go from there and make sure you check it. You have to mark it. There's a whole bunch.
See if I could make
major GCs aren't always slower.
So what I did here was I allocated just some random stuff in a loop. Looking at the trace, we did spend quite a bit of total time in minor GCs. Wall time is nearly 10% of the time, in fact, although each singular call to minor GC was just shy of 2 milliseconds, so not quite the crazy long time major GC took. I took another stab at it by allocating sparse arrays and just randomly setting values in there, and V8 kind of laughed that attempt off. Nearly 800 minor GC calls, but they ran in a pretty negligible amount of time. I consider 10% to be pretty bad, but simultaneously it's a ridiculous setup. So maybe instead, let's build a somewhat more plausible game setup to see the effects of GC in action.
I'm not sure if games are the best measurement, because games theoretically also have, what's called some dead time, some idle time. Theoretically, I know that's not quite it. You usually have every single team have some sort of allowance they can each have, so that way things can all run together. I get it. That's not how it actually works. But in a lot of simpler games, you have a bit more dead space. Whereas if you're on a server and you're just constantly hitting as many requests as possible and you're at load, every GC makes a real impact into requests. You'll actually see a slowdown in requests per second due to GCs. Anyways, keep on going.
Here's a quick and dirty game setup. So what I've done here is a super basic bare bones game in quotation marks. I don't bother actually rendering any of this, but we do simulate the entities. So you've got this list of entities we call update on each one. When they die, we destroy them, then filter them out. And we keep a stable population by creating new ones in their stead. The entities themselves do some legit work, so they have a transform data associated with each one, along with values like energy, health, and they have a spatial hash grid client to track their position in the world.
You ever hear the story about how quaternions were invented? I forget who it was. I want to say Hamilton is the correct answer. But apparently walking with his mother-in-law, if I'm not mistaken, and then etched the quaternion formula into a famous bridge. So clearly, whatever his mother-in-law was saying, either A, was exceptionally inspiring, or B, was so boring that the only thing you could think of was imaginary numbers. Just saying. This man have video on quaternions too. Oh, really? Okay, cool. Yeah, I did. I explored a master's in graphics as well. I did a lot of exploring, as you guys have. You probably heard by now. You're like, wait a second. You've told me you've tried to do a master's in AI, software engineering, graphics, algorithms. What the hell haven't you done? Okay, I spent a couple years in school, maybe learning. Maybe I was really into it, but ultimately, unfortunately, academia killed the rock star. What's the video? Video killed what? Video killed the radio star? That's what I was trying to quote, and I got that way wrong. I can't even remember it now.
Other entities. They also have this update function.
I'm not a rock
star. I forced them to do some random stuff. I didn't feel like making the logic extensive, so I just repeated a few times. When they're fully charged, they shoot off a bullet, so they create a bullet, and that's added to the world.
Let's just face it. When we're fully charged, we all shoot off bullets, if you think about it.
Bullets are their own thing. They have a full transform. Their position is updated according to velocity, and eventually they explode and kill nearby things. So it does some stuff. I took a few traces of this running, chose a bad one, and we can poke around in here a bit. If I select the first 10 seconds or so of the trace, we can see some numbers for minor GC and major GC.
Look at that, major GC is shorter in here. You see that major GC right here? Average CPU, but either way, 1.117 versus this one was, whoopsies, I was reading the first one, that was 3 seconds. Never mind.
500 or so minor GC calls, taking on average less than half a millisecond, but adding up to around 240 milliseconds or so. There's not many major GC calls, barely any actually, but the ones that do fire take a little over 1.1 milliseconds each. There was always going to be some overhead for garbage collection, but at the same time, this is written super poorly. Realistically, an experienced game developer will code with memory allocations in mind. So let's make this a tiny bit better. I've got a slightly improved version of these entities that attempts to minimize allocations. Nice. In the main loop, we actually reuse entities instead of allocating new ones, and the entities themselves use pre-allocated matrices and vectors. I
swear I just constantly harp on this all the time.
Crazy here. Looking at a trace of that version, though, we can see a monster of a difference. Whereas before we had around 500 minor GC calls, this version gets 110 or so, and a touch over 50 milliseconds of total time spent there.
That makes a huge difference in request per second. There's one major GC call
accounting for another millisecond of time. One really interesting thing that stands out here is that in the first example, let's zoom in and look at these minor GC calls. They're happening during the frame, sometimes multiple times. Meaning that they're contributing to longer frames. In the second example, they're happening in the idle time between frames, which is totally by design. V8 specifically built this feature into Chrome. When it detects there's an idle period, that's where V8 has the go-ahead to quickly run GC. What I kind of got from all of this was that short-lived objects are often pretty cheap from a GC perspective. That doesn't mean they're free though, but if you can get them down low enough, they may just run in the idle time between frames and you may not see much in terms of overhead for it. The more crap you keep in memory, the longer-lived cache stuff, the more expensive your major GCs are, as we saw with my stupid synthetic test.
I love this. I love this video. I feel like this is just a much better version of what I've been yelling at all of you guys about for like the last 2 years. This is fantastic. Simon Dev, you're a genius.
I know my own code though, usually. So this could probably be at least partially mitigated in the future by just letting me tell you via some sort of API that gives hints to the garbage collector. Something like that. I don't know. I've given this a full 10 seconds of thought. You'd need to actually plan this out more.
Yeah.
One major problem with JavaScript, though, is that although for your own app, you might be able to control your allocations, with third-party stuff, you have very little control, as far as I know. I mean, in something like C++, it's sort of the same deal, but at least you can override memory allocation at a global level, and depending on your application, extend this to third-party libraries as well. In JavaScript, no such luck. I can't isolate a third-party library to its own memory pool, so that's just something you have to live with. Another thing is that, yeah, of course there's a cost to having GC. Direct management will be more performant when done right. But in reality, decently made games don't just allocate and free on a whim either. Most do it in a very controlled way. I've spent enough time moving systems to different allocation patterns, linear allocators, pool allocators, LIFO and Scratchpad style frame allocators in order to wring out extra performance. C++ programmers may love to toot that horn, but even among game devs, that was usually handled by just a few people at the studio, not everyone. In JavaScript, you have some control over memory, but it's pretty tenuous. Mostly it's down to your pattern of allocation, minimizing allocations by reusing objects, that sort of thing. Maybe you could go crazy using type.
This is one reason why I really love using classes, is that classes are extremely easy to reuse. Not only do you give the exact blueprint you're going to have to V8, assuming V8 is attempting to optimize things, like that is one of the best things you can do, is like, here's the exact thing that I want every single time. Right? So it's fantastic in that sense. And then second, it's extremely easy to reuse a class, because a class, you can just make a method reset. Bloop. Like, like a really good thing that people don't realize is that wherever you have to add a bunch of callbacks, right? Especially like WebSockets, you have like a server that unconnects a bunch of WebSockets. Those listeners aren't free. It's a little bit shocking how expensive those listeners can actually be. And so by taking control of that and having a class that binds itself to methods, and then you just simply hand those bound methods every single time, and when you reset, you unlisten. A, you have pretty easy lifecycle management, but B, it actually allows you to not recreate those handlers, because not only do you have a function, you're also creating a bound function, which is a function holding onto a function that gets held onto for a long time. It just adds in a lot more, right? So it's very, very interesting.
It's fun. But let's save that for another time. And lastly, how much memory overhead does JS incur for doing all of this?
I do not believe classes have instantiation costs like you're saying. I think it's significantly less. If you ever have to use a raw object, first off, you have to have an API that is not attached. You do not get free LSPing, okay? So baloney, right? And second, you're going to have to, what I mean by that is like, okay, so if you have so you could imagine you have some sort of const, you have some sort of type, foo that has, oops, I always forget that. You have some sort of foo that has X string, Y string, Z string, there you go, right? Fantastic. This object exists. And then you also want to be able to have some functions like do foo1. It takes in a foo, and therefore it takes in a foo, and it returns out, I don't know, a boolean, return, I don't know, foo.x plus foo.y. Look, string concatenation. Rope strings equals foo. Why not, right? Okay, fantastic. Now, the thing about this is that this is going to exist in some sort of module somewhere. And so instead, if you have class foo, which does have all these exact things up here, right? Paste those all in, blah, blah, blah. At least if you have do foo up here, right? You can do something that's a little bit nicer here, which is when you instantiate one of these, you at least get foo up, hold on, 11 up. Here we go. Let's go 1, go down here. And go foo1, right? Const foo, what is it? Foo, we'll call foo1 equals, I don't know, new foo1, there we go, blah, blah, blah. At least when you do this, you at least get the method, right? You get the things hanging off versus when you only use flat objects. First off, taking flat objects and you need to reuse them means you have to delete properties off of them. Deleting is very, very slow. You also get these structural problems. There's all sorts of crazy things that happen. But B, you also have just like basic LSP bullshit. You have to know where this method is. And if there is literally like still 15 or 20 of these different functions, you have to know of all the functions, or you have to go to the file to go look at it, or you have to do what I think is one of the worst things, which is import star as, foo functions from, from foo, right? And that is like the most annoying thing. Then you're looking on this thing for the objects of foo. Then you call, do foo, and then you have to pass in the foo itself. I hate that. I don't want to do that, okay? Because then not only that, you can't chain. Then chaining totally sucks because now you have to this whole like foo function, do foo to, go bid that, right? Like even if you pass foo back out, it still sucks, right? Like I hate that. I hate that. I understand people in the JavaScript world love their functions and objects, but it's super, super, super annoying having all that crap. Sorry, end of rant. Way, way easier to have a reset function. Way, way easier to pool objects. That's just why I tend to just lean on classes. The end.
How's the performance on Firefox? Etc., etc. Great questions. No idea. Didn't test those. Maybe next time.
Love that answer.
Throw some comments about what you'd like to see tested in the future. Until next time.
Thank you, Simon. Great guy, Simon. Hit that subscribe button right now. It'll be linked in the description. Absolutely loved it, Simon. Perfect talk. Loved it. Yeah, give him some clappies. Give the man some clappies. Hit that subscribe. Are you still using Alacrity? Of course. I never used Alacrity. I use some terminal from the 80s. You know why? Because I don't care. My terminal is fast enough. I don't need your GPU rendered text. Okay? I don't need it. When I press zoom, it just bumps up the font size. Okay? I don't need font size 420.69. Okay? It doesn't matter to me. I just need 420 or 421. I don't care. Okay? I don't care. That's that. Simon's a genius? Absolutely. Clearly genius. Beautiful voice. The end.